California, 2020. Wildfires rage all across the state, as they have been for the past few months. The August and North Complex fires have devastated acres of Northern California, while others inch closer to the Bay Area and even more threaten Sequoia National Park and Los Angeles in the south. The causes of these wildfires are even more distressing. The dry summer heat has left state forests vulnerable to combustion. A single lightning strike, campfire, or a cigarette can level miles of terrain. It's clear how bad this bodes for California. 80% of all wildfires are caused by human carelessness, and the rapid acceleration of climate change has led to this year's wildfires being the most devastating. Of the 10 largest wildfires in California this decade, 5 burned just this year. Ultimately, 2020 has seen the ravaging of 3.2 million acres of Californian land, destroying not just animal habitats but also people's homes and livelihoods. So much so that they don't even have a fighting chance. Wildfires are hard to predict and hard to detect, since they spread quickly. Our product can detect when we can't. It is called FireSense.
Hello, my name is Arjun Tschand. Our team also consists of my fellow ninth graders Sharabh, Ojha, Anish, Pallati, and Nikhil, Osuri. To begin, for the hardware component and prototype, as shown here, we utilized a Raspberry Pi and ran Python code on it. In addition to this, we used a servo motor along with a USB plug-in Logitech webcam that attached to the servo motor. When the servo motor spun at intervals of 18 degrees, the webcam would continuously overwrite a .jpg file, convert it to base 64 encode, and then send it to the server to be decoded. Also, we constructed a wooden base to act as a structure for the motor and camera to be placed on. To give it additional height, a metal rod was placed vertically. To actually test our FireSense mechanism, I created a plastic dome with different colors and tested to see the FireSense take pictures and analyze them. Here's the dome that we created, and here is the mechanism in action. So after the images were taken, we used a Python web server made using Flask. We used REPL.it as a temporary host, and it has two endpoints, the get and the post, and the /send is how the camera sends an image to the server. It also uses, so when the image is actually analyzed, it uses OpenCV and NumPy to process the image. This consists of creating a BRG color range, which is a RGB reversed, and creates a mask using these values. The original image is then converted from RGB to HSV for higher accuracy, and the mask is applied on the original image. Here's an image of what we used to test this. And this, the result is a black image where only colors that fit into this range are visible. The non-black pixels are counted and are used to calculate the percentage of picture that falls under that range. If this percentage is under 10%, it is ignored. However, if it's more than that, it is uploaded to the Firebase Firestore, which is used by the front-end website to display the data. It is also saved to a .csv file, which is uploaded to EazyML. Coming back to our mechanism, here's what FireSense was able to capture from the dome. Taken at different times but the same angle, this is how the increasing amount of orange was analyzed, and when I reached over 10%, it was uploaded to the interface.
My name is Nikhil, Osuri, and I worked on the website portion of this hackathon project. The purpose of my website was to display the data that we got from the FireSense mechanism and the database in a concise fashion. I displayed the camera number the picture was taken from, showed the orientation of the camera in degrees, gave a percentage of the possible fire intensity in the image, and finally gave the time the picture was taken at. I achieved this task by using Flask, JavaScript, Python, and a Heroku-hosted website.
In just one day, our team has managed to make a fully integratable camera system that can detect fires before even park rangers and government agencies. The amount of lives this could save is absolutely astounding. Through EazyML and our constantly updated website, the pictures taken by hundreds of these cameras could alert citizens to what could be a deadly wildfire approaching. But why stop at California? As global warming becomes even more of a threat and the world has to adjust to harsher climates, we can use this tool to save people around the world from wildfires, thanks to the product we know as FireSense.